So here we have at 7 and we want to know what's happening at here at 1 o'clock. Oh, sorry, it's 1 o'clock. Shouldn't it be here? 1 o'clock and at 7 o'clock. Okay. Now, the temperature is 11 degrees higher than the temperature at 1 o'clock. So here it's -3. It must be 11 degrees higher. So what's here? So x plus 11 must be -3. So x must be -3 minus 11. X is -14 degrees. Got that? Okay?
Yep.
Okay. Jody swims 22 length of a swimming pool to raise money for charity. She receives 15 for each length. Calculate how much money Jody raises for charity. So that's very easy. 15 times 22, which would be, how much is it?
330, I think.
330. There you go. Question 3. The recurring decimal. Okay, what is recurring decimal? Recurring decimal, it simply means that it's keep the numbers are repeating at the back like this. Okay. So when we have this number, we try to make this whole. So to make it whole, I have to move it 2 times, right? So this will give me 100x must equals to 23.23. Got it? Now my x is 0.23. Now to solve this x, I simply have to minus 99x equals to 23. So x is 23 over 99. So this is in the form of fraction. So what you can do to double confirm this, you can key in your calculator 23 divided by 99. You will get the answer 0.2323. So the answer here is 23 over 99. Guys, got this? Can understand?
Yeah, it's basically you want to get rid of the recurring decimals at the back.
Yes, we just want to get rid of the recurring decimal at the back. That's what we want to do here.
But if 0.23 times 100 is 23,
Sorry?
0.23 times 100 is
No, here it's recurring. So it has to be 0.232323. It keeps going only.
okay.
So we just stop at 4 lah, like that. So if I times this equation by 100, I'll get 23.23. And 1x will be 0.23. So what I'm doing is I'm getting rid of the back number here. So I will get a whole number. So once I have the whole number, I figure out my x. Okay?
Okay.
Now, two significant figures would be, because we have decimals in front, the two significant, we have zeros in the front, the two decimal figure will start from here, these two, right? So your answer should be 0.047. Why it's 7? Because this is 8. So we just have to increase this by one number. So that's your answer here. Okay? Now the next question. Now if you want to write this in standard form is when you have times 10 to the power of n. So the n is determined by how many times you're going to move your decimal point. So here, 1, 2, 3, 4, 5, 6. So the standard form would be 2.76 times 10 to the power of how much again? 6. 1, 2, 3, 4, 5, 6. Yes. So 2.76 to the power of 10 to the power of 6. This is standard form. Howie? Can?
Yes.
Okay. The next one. A tourist changes 500 to dollars to euros when the exchange rate is this. So simply write down 1 euro equals to 1.0697. So how many dollars is this? 500 equals to x. You don't know. So simply what you have to do is cross multiply to get an answer. So 500 equals to 1.0697x. So x must be 500 divided by 1.0697, which gives you 467.42 euros. The bearing of Alexandria from Paris is 128. Now let's draw that first. So let's look at that. That's your north. The bearing of Alexandria from Paris is 128. So now this is Paris. 128 will be somewhere here, right? So there. So the bearing of uh, what do you call it? The bearing of Alexandria from Paris. So from here to here, so this must be Paris. This must be Alexandria, right? Calculate the bearing of Paris from Alexandria. So from Alexandria, it should be this entire thing, isn't it? Because we always start from 0, you go clockwise. So if this entire thing is 128 degrees, now we know this is a parallel line, isn't it? So you have a parallel line like this. This is 128. Now what do you know about the rule, the behavior of this? That the two angles should sum up to, because it's a parallel line. So two angles, in internal angle of these two parallel lines should sum up to 180. So 180 minus 128 should be 52. So we know this angle here is 52. So the entire bearing for this should be 360 minus 52, which would be 308 degrees. Okay, so the bearing of Paris from Alexandria would be 308 degrees. Okay, now how do you calculate the surface area of the cuboid? Give it a try.
Yeah.
Okay, now let's look at this question. Okay, calculate the total surface. Now, total surface area means you have to calculate each of the surface area, right? So how many sides does this cuboid has? 6 sides, isn't it? So each side's area must be calculated. So this part here we have 2, right? Front and back. Now this part here we have 2, and the bottom and top part we have 2. So if you know surface area of A times 2, B and C, you get the total surface area. So surface area should be 2A plus 2B plus 2C. Now what's your 2A? 2A is 12 times 7.5, right? Plus 2B. B is 5 times 7.5. And C would be 12 times 5 here. Okay, so here this is 180 plus 75 plus 120. So the surface area should be 375 centimeters square. So percentage increase. How would you do a percentage increase? New minus old over old times 100, right? So just remember, for percentage increase or decrease, we just use this formula. Give it a try. Okay.
Yeah.
So the new value is 77, the old value is 63. Divide by the old value times 100. So how much is this? 77 minus 63 divide 63 times 100. So it's about 22.22%. Now volume, give it a try. Let's do question number 12 first. Now let's look at this question. A cone with a height of 14. Let's see whether I can draw the cone. Now we have a height here. Okay, a cone with a height of 14, so this must be 14.8 cm. Volume is 275. They want you to find radius. Now, you guys are lucky, they have actually given you the formula. Just work with that. So, V equals to 1/3 pi r, which we don't know, but we do know the height is 14.8. Sorry. 14.8, and the height is 275. The volume of the cone is 275. So all we just have to do is work with the equation and find r. So 275 must be 1/3 times. So that would be 15.504 r squared, or 05 r squared. All right. So r squared should be 275 over 15.0505. So 17.74 is this. So then what we have to do, we have to root our 17.74 for us to get r. So root the answer, r would be 4.211. There. Howie, I'm going to discuss the first one.
Yes.
Okay, how do we factorize this? It's very simple. We just take the common denominator here. Now, how do we factorize this? We just take the common variable. Here, the common variable is k. So once I move my k outside, what's left is 7k minus 15. Can I simplify this further? I can't. So this is the answer. K, 7k minus 15. Okay, the next one. Now for this question, we don't have to expand it all the way. We will treat them this as one entity and this as one entity. Okay. So for 12 and 8, what can we take it up? Now treat this as one and treat this as another one. Right? So 12 and 8, I can take out 4, right? When I take out 4, what's left? I'm left with 3m plus p, right? Plus 2m plus p squared. Right, now, what else can I take out? What else can I take out? The same similar factor here is m plus p. So 4m plus p, if I take this out, what I'm left here is 3 plus 2m plus p. Got it? So I just simply have to expand this part, which will give me 3 plus 2m plus 2p. So that means 4m plus p bracket 3 plus 2m plus 2p. So that's the factorization for this. So you don't have to open up everything, because once you open up everything, it becomes very complicated. So you factorize as two different entity and you see it as one. Then it's easier to work with. Okay.